So we've got a car of mass 1500 kilograms and it's travelling at a speed of 20 meters per second. Now the driver wants to overtake a lorry. Now to do so, she accelerates to a speed of 40 meters per second in 4 seconds. Now first thing we've got to do is we've got to calculate the car's acceleration. So we need to remember the expression for a body that's moving with a constant acceleration, and that is that A, that's the acceleration of the body, is equal to the change in velocity. That little triangle means change in physics, divided by the time taken. Now let's have a closer look at this delta V. What exactly does this mean? Well, it's the change in velocity, so it's the final velocity of the body minus the initial velocity. Okay, that little I means initial, the F means final. Final velocity minus the initial velocity divided by the time taken for that change in velocity to take place. And in this problem we see that the final velocity is 40 meters per second. Now in many problems in physics, typically the body will start from rest, but you need to note here that the car isn't at rest at the moment. It's not stationary, it's moving with a speed of 20 meters per second. So its initial velocity is 20 meters per second divided by the time taken to change velocity, which is 4 seconds. That equals 20 meters per second over 4 seconds, which is equal to 5 meters per second, or 5 meters per second squared. So typically the next stage in a problem like this would be to calculate the resulting force acting on the car that helps it to accelerate. So here we're being asked, what is the thrust applied by the engine in order to overtake the lorry? So we need an expression that relates the resultant force acting on a body to its mass and acceleration, and that expression is Newton's second law. Okay, so you've got to recognize here this is a Newton's second law problem. We've got thrust, which is a force, we've got the mass, and we've got the acceleration of the body. Okay, and that is F equals m times A. Okay, in this particular case it's a simple question of substitution. We just need to substitute the mass of the body, which is 1500 kilograms, and its acceleration, which was 5 meters per second squared, and that gives us a force of 1500 times 5, which is 7,500 newtons. So this force is acting on the car to give it an acceleration of 5 meters per second squared as it overtakes the lorry.